Here's a quick review from your research that you've been doing in class. The mole is the quantity of any chemical that has the same number of particles as 12 grams of carbon-12. We call this an SI base unit. Avogadro's number is 6.022 times 10 to the 23rd atoms, and this is how many atoms are found in 12 grams of carbon-12. Molar mass is the mass in grams of 1 mole of any substance. And finally, Avogadro's number is the number of particles in a mole of any substance. So 6.022 times 10 to the 23rd particles is equal to 1 mole of any substance. Before we can use calculations with the mole, we need to learn how to calculate molar mass. You're going to need your gold sheet with your periodic table on it in order to do this. We need to calculate the molar mass of calcium nitrate. In order to do this, we need to look up the masses of calcium, nitrogen, and oxygen. But before we do that, we further have to figure out how many atoms of each element are in the compound calcium nitrate. That's the easy part. We learned how to do that a few units ago. When we look at the formula, we see that we have 1 calcium. So 1 calcium. 1 calcium. And when we distribute the 2 into the parentheses, we have 2 nitrogens and 6 oxygens. Now looking up the masses on the periodic table, we see that the mass of 1 calcium is 40.08 grams per mole. 2 nitrogens, we take 2 times the mass off the periodic table, 14.01, and we get 28.02 grams per mole. For oxygen, oxygen's mass is 15.9995, so we just round that to 16. So we'll take 6 times 16, which gets us 96 grams. When we add all of these up together, we get 164.1 grams per mole. Another way to say this is that there are 164.1 grams of calcium nitrate equal to 1 mole. Copy this down. We're going to use unit conversions in order to make our calculations between moles and grams and particles. We use a method called dimensional analysis. In order to use dimensional analysis, we use a particular pattern. The given value in unit is written down first. And then we build what's called a conversion factor. Basically, we're going to multiply a number by a fraction. The unit you want to get rid of goes on the bottom. And the unit to get to goes on top. And this pattern gets repeated for as many types of unit conversions as we need. For example, let's say that you jumped 3 feet. How many inches is this? Well, you already know it's 36 inches, but here's how you know. We can convert 3 feet into inches using dimensional analysis. The unit we want to get rid of is feet, so we put that down here. And the unit we're trying to get to is inches, so we put it up on top. We know that there are 12 inches for every 1 foot. And whenever we multiply a whole number by a fraction, we multiply the numerator and we are sure to divide by the denominator. So 3 times 12 is 36, divided by 1 is still 36. And so we get 36 inches are in 3 feet. In the next 2 slides, I'm going to show you how to use dimensional analysis to convert between particles and moles and grams and moles for our investigation of how we quantify chemical reactions. In the last slide, I asked you to copy down the mole map. I have another picture of it here at the bottom right-hand corner for our use in this example. If you did not copy this down, please copy it down now. For our first example, we're going to look at how we calculate the number of moles that are in 8.32 times 10 to the 26 atoms of iron. Atoms here tells us that we are going to be looking for a way to get to particles. Please stop the video and copy down this example. Alright, let's see how we go about using the mole map and dimensional analysis in order to figure out how many atoms of iron are in 8.32 times 10 to the 26 atoms. We need to have a strategy. So let's pick out a strategy. Okay, our strategy here is to go from atoms of iron to moles of iron. And when we take a look here, to go from moles to particles, we need to use Avogadro's number, 6.022 times 10 to the 23rd. So let's use that as a dimensional analysis setup here. Alright. So we now need to create our equality. We call that our known. And we know that there are 6.022 times 10 to the 23rd atoms of iron in 1 mole of iron. The last thing we do is calculate. We're going to use dimensional analysis. We haven't used this since chapter 1. You will have to look it up if you're not sure where I'm getting everything from. But if you recall from chapter 1, whenever we run a dimensional analysis problem, we always write our given value first, including the units. So we have 8.32 times 10 to the 26th atoms of iron. Then we build our conversion factor. I don't want that guy. No. Alright, hopefully I don't run into this guy. So then we build our conversion factor. We want to get rid of atoms, and whatever we want to get rid of goes on the bottom. So we're going to put atoms on the bottom of iron. And we want to get 2 moles of iron. So when we look here, again, we're going to go from moles to particles using 6.022 times 10 to the 23rd. So there are 6.022 times 10 to the 23rd atoms of iron in 1 mole of iron. When we do this math, and we put it in the calculator, remember to use your EXP button or your EE button on a TI. We get a calculator answer of 1,381.6 moles, but because of sig figs, we started with 3 sig figs over here. We can only keep 3 sig figs. Our final answer is 1,380 moles of iron, and that is our final answer. Before we start example 2, please stop the video and copy down the problem. Okay, this problem is a little bit different than the first problem. This problem asks us to calculate the mass in grams of 14.32 moles of sodium chloride. In order to do this, we need to look at our mole map, and we're going to be going from moles to mass. The row tells us that we have to use molar mass using the periodic table. So let's take a look at how we do that. If we need molar mass, that means that we need to add up all of the atoms' average atomic masses off the periodic table, which means we need the formula for sodium chloride. It's a good thing that we know how to write formulas, because we know that sodium chloride is NaCl. So we need a strategy. Our strategy this time is to go from moles of sodium chloride to grams of sodium chloride. I'm going to have you work out the strategy, the known, and the calculation for all of your problems at the beginning here, just until you get used to what you're doing. So make sure you copy all of this down. Alright, now our knowns. We need to know the molar mass, okay? So when we look up 1 sodium, we see a mass of 22.99. Oh, let me put the A in for sodium. Hang on one second, let me erase this. So 1 sodium atom is roughly 23 grams, and 1 chlorine atom is 35.45, for a total of 58.45 grams of sodium chloride is equal to 1 mole of sodium chloride. That is molar mass. 58.45 grams is the mass of sodium chloride in 1 mole of sodium chloride formula units. Alright, let's get to the calculation. We always start with what we're given, so we're going to start with 14.32 moles of sodium chloride. We want to get rid of moles, so we're going to put moles at the bottom. And notice I'm putting the unit and the chemical. We have to do that in order to be counted correctly. I will mark you wrong if you don't do this. We want to get to grams of sodium chloride, and our numbers follow. The grams is 58.45 to 1 mole. When we do that math, we get a calculator answer of 837, let me write this down, 837.004. But we know our sig figs, and since we started out with 4, we can only keep 4. So our final answer is 837.0 grams of NaCl. And that, ladies and gentlemen, is our final answer. We'll continue to discuss the concept of the mole and the mole calculations tomorrow in class. I hope you have all of these notes. Make sure you copy down all of the problems. Have a nice night. See you tomorrow.